I'm delighted now to be joined in studio by Dr John Breen, who's the Chief Technology Officer at NEG8 Carbon, and he's going to explain to us what this is all about. John, how are you? Good evening.
Hi, Mary.
How are you?
I'm very well, thank you.
Good, congratulations. NEG8 Carbon has really made great strides in its relatively short existence, but it's an advanced science, it's a complicated science in ways. So for our listeners who are not familiar with NEG8 Carbon, can you give a kind of a summary of who you are and what you do?
Okay. Yes, we're a spin-out from Trinity College in Dublin. The company itself was founded in 2014. They developed some very nice technology in the university and got significant funding on board in 2021. At that stage, the company moved down to Waterford. I started to build out the team here in Waterford. We're a team of 12 now. So we have a 1 tonne per annum carbon capture device that we have had on site in our Waterford premises since 2023. And that's been running very well. We've also developed the technology during that time. We're on to our 3rd generation of our carbon capture technology, and that's the one that we will be scaling up. It's a very exciting patented technology that is unique electrostatic technology to capture CO2 from the atmosphere.
Okay, so I suppose the whole concept of carbon capture then, can you delve in a little bit more into what you mean by that and why it's important and useful, in terms of protecting the environment?
Yes, so we've put nearly 1 trillion tonnes of CO2 into the atmosphere since the Industrial Revolution, primarily from burning fossil fuels. And it's the primary cause of climate change. At the start of the Industrial Revolution, we had 280 parts per million of CO2 in the atmosphere, and that's now up to nearly 430 ppm. So we've more than 50% increase in CO2 levels in the atmosphere.
And this is across the world, right?
This is across the world. So the thing about CO2 is it spreads around the world from the point where you combust it. So it's pretty much the same concentration in the atmosphere all over the world. Okay,
so whether you're China or Ireland, you're going to have the same amount of CO2 because of the industry that's happening globally, basically.
Exactly. CO2 that we emit here eventually spreads all around the world.
So when it's being captured then, what's happening there?
Yes, so essentially what we do is we've got big fans on our machines, and they suck large amounts of air through a special material called sorbent. And that selectively takes the CO2 out of the atmosphere and allows all the other gases to pass through. And then it's like a sponge, really. Mm-hmm. So you fill it up with more and more CO2 over a couple of hours. And when it's full, you do the equivalent of squeezing the sponges to remove the CO2 and water by applying heat and vacuum. And you end up, once you've separated the water from the CO2, with a very pure CO2 stream.
And where does the CO2 go then?
Well, that's a good question. And there's a range of different end destinations for the CO2. Essentially, if you think why we're doing this, we're trying to lower the CO2 concentration in the atmosphere. One thing that you can do is bury it underground, essentially where it came from as a fossil fuel. So you can put it into depleted oil and gas wells. You can also put it into materials that mineralise the CO2. So we have a project with an Irish cement company where we capture the CO2 and they inject the CO2 that we capture into concrete. And that has advantages. It makes this concrete stronger, and they can use less cement, and it's locked away for good.
So you're doing this direct air capture then in different parts of Ireland and the world, am I right in saying?
That's correct, yes. We have another project that's funded by the UK government, their Advanced Fuel Fund. And this is an interesting one because what you can actually do is you can take the CO2, react it with hydrogen that you produce from an electrolyzer. You bring those two molecules together and you can make fuel that can be put in airplanes. Or you can make methanol that can be used to power ships. So then it's circular. You're not taking more CO2 or fossil fuels out of the ground. You're capturing it from the atmosphere, making fuel, and then the airlines can burn that fuel to take you across the world.
Are you the only company doing this?
We're not the only company doing this. There are companies around the world developing different forms of the technology.
Are you the only company in Ireland?
We're the only company in Ireland that's producing large-scale carbon capture devices.
Why Waterford?
Why Waterford? There's a very good infrastructure here in Waterford. First of all, we had the ability to use the facilities at work and Kinetic Labs, which is fantastic. It's an incubator that's available near the industrial estate on the Cork Road, just around the corner from SETU. And we've really greatly availed of all the facilities at SETU. We've had projects with the Walton Institute, the Southeast Additive Manufacturing Centre, the MBRC, and local companies then. So it's been a very good location for us.
So talk to me then about this new agreement. So basically this is an agreement for an engineering study to define the detailed project specifications of Ireland's first full-scale carbon capture system, and this is you guys working with ProChem Engineering. So what do you hope to achieve from this then?
Yes, so we've had a 1 tonne per annum unit operating in our facility here since 2023. We've brought it through the generations of the technology, and now we're scaling up to produce our first full-scale unit that'll capture 50 tonnes of CO2 per annum. That's a big step forward for us because that's the building block upon which all our future machines will be built with. So, for example, we'll put 5 of these 50 tonnes in a 40-foot shipping container to modularise our solutions. So it's a big step forward for us. It's the first full-scale carbon capture, direct air capture equipment in Ireland.
So you're still a kind of feasibility study stage with it, are you?
Well, we've proven out at pilot scale using all the technology that we're going to use at this larger scale, but this is about taking it to the next scale. So this is going from pilot scale to full scale.
Okay, so so this unit will be based in Waterford, but can it be moved as needed then? Is that the plan, or how does it work?
Yes, so as you say, ProChem are doing the engineering design at the moment. We'll go on to the detailed engineering, and we plan to have the device at our site here in Waterford in Q3 this year. And it'll be set up on our premises, and we'll test it out essentially, and use all the results of those tests to further produce our larger scale units for projects that we have now in the UK and Ireland.
Will you have to scale up capacity considerably if, the study is kind of shows that what you're doing is viable? Like, will it be a case of kind of scaling up manufacturing considerably, maybe finding a bigger premises? Like, are you looking at things like that because of the work you're doing at the moment?
Exactly, yes. I mean, scalability is key to this.
Yeah.
Because if you think about, if we want to make a change to address climate change, and this has to be done at a massive scale.
Yeah.
So, we're talking about thousands, tens, hundreds of thousands, millions of tons of CO2 that we need to take out of the atmosphere. So scaling is very, very important. But the design that we've built now, we think, is very readily scalable.
Okay. And will it be you guys who'll scale it, or will you kind of team up? Will there be public-private partnerships in your future? Like, how do you see kind of making this more kind of a widespread thing?
Yeah. So our R&D team is based here in Waterford.
Yeah.
Undoubtedly, we'll get component parts made from different parts of Ireland and indeed the world. But the plan is to bring them here to Waterford to do the final assembly and testing, and then ship out around the world essentially. So this is really a large-scale technology. It's hardware, so it's going to need a lot of people, a lot of highly skilled people, and we plan to do that all here in Waterford.
Are you currently actively hiring, or?
We have some positions open at the moment, for sure, but we will be scaling the team. We're a team mostly of engineers at the moment. We'll be bringing on more engineers to take us to the next level, and all the sort of backroom staff that a company such as ours will need.
So it's a great news story, I suppose, this agreement with ProChem Engineering, but also the plans you have. Like, it's, you know, I mean, the trajectory has been quite rapid, hasn't it, in terms of the growth of NEG8 Carbon?
It's been very rapid, yes, yeah. But that's what we need. You know, the climate change is, as you know, it's an urgent problem that needs to be addressed. So the faster that we can do it, the better. And we're very confident that our technology is a solution.
Okay, great stuff. Dr. John Breen, CTO of NEG8 Carbon. It's always great to talk to you guys. I think what you're doing is phenomenal, and the fact that it's happening here in Waterford is all the better. Thank you very much for coming in to me this evening.
Thank you, Mary.